Network elements classification. Network elements are broadly classified into four types: active and passive elements, unilateral and bilateral elements, linear and nonlinear elements, lumped and distributed elements. Network elements classification. Active elements. An element is said to be active if it delivers power to some external device. Example, voltage and current sources. The figures given below are active elements. Active elements. Voltage and current sources. Network sources are classified into two types, namely independent sources and dependent sources. Independent sources are again classified into voltage sources and current sources. Voltage sources are of two types, namely ideal voltage source and non-ideal voltage source. Similarly, current sources are of two types, namely ideal current source and non-ideal current source. Dependent sources are classified into four types, namely voltage-controlled voltage source, current-controlled voltage source, voltage-controlled current source, and current-controlled current source. A detailed description of each type is given in the preceding slides. Independent voltage source is classified into ideal voltage source and non-ideal voltage source. Ideal voltage source. An ideal voltage source is an element capable of generating a specified voltage across its terminals irrespective of current flowing through it. In the above figure, Vs is the ideal voltage source, V is the terminal voltage, and I is the current. The given source represents the voltage-current characteristic of an ideal voltage source. Here, the terminal voltage V is independent of the terminal current I. Hence, the graph is a straight line. Non-ideal voltage source. In practice, when a load resistance is more than 100 times larger than the source resistance, the source can be considered approximately as an ideal voltage source. In other words, the internal resistance of the source can be omitted. The practical voltage source is characterized by two parameters, namely open circuit voltage and internal resistance in the source's circuit model. In a non-ideal voltage source, the terminal voltage decreases linearly by increasing the current. The source is connected in series with internal resistance, and this combination is connected to the load as shown in the figure. There are two types of independent current sources, namely ideal current source and non-ideal current source. Ideal current source. An ideal current source is an element capable of generating a specified current which flows through the terminals irrespective of the voltage across it. Voltage-current characteristic of an ideal current source is shown on the screen. Above characteristic shows that in ideal current source, the current is independent of the terminal voltage. The ideal current source is directly connected to the load and no other element exists between them. Non-ideal current source. In practical current source, internal resistor is included parallel to the source. The expression for current flowing through the circuit is obtained as follows. From the circuit, source current Is is equal to voltage V divided by internal resistance RINT plus current I. I is equal to Is minus V divided by RINT. The graph between voltage and current shows that the current decreases with the increase of voltage. Dependent sources. A circuit involving dependent source is shown on the screen. A diamond-shaped symbol is used to represent the dependent sources. The source whose output voltage or current is a function of the voltage or current in another part of a circuit is called as a dependent source. The various types of linear dependent sources are shown on the screen. Passive elements. Passive elements are able to store finite amounts of energy and then return that energy later to various external devices. A passive element is one which is capable only of receiving power. Resistors, inductors, and capacitors are some of the examples of passive elements. The below figures are passive elements. Passive elements. Resistors. The property of a material to restrict the flow of electrons is called resistance, denoted by R. The resistance of a resistor depends on the material of which the conductor is made and the geometrical shape of the conductor. The resistance of a conductor is proportional to its length L and inversely proportional to its cross-section area A. Therefore, the resistance of a conductor can be written as R proportional to L divided by A, or R is equal to rho multiplied by L divided by A. The proportionality constant rho is called the specific resistance or resistivity of the conductor. L is the length of the conductor measured in meters. A is the cross-sectional area measured in meters square, and R is the resistance measured in ohms. Thus, resistance is the property of a circuit element which offers opposition to the flow of current, and in the process electric energy is converted into heat energy. Passive elements. Inductors. An inductor opposes sudden changes of current and it stores energy in the form of a magnetic field. Inductors are made with many turns of thin copper wire wound on a magnetic core. Unit of inductance is Henry and is represented by capital H. Passive elements. Capacitors. A capacitor opposes sudden changes of voltage and it stores energy in the form of an electric field. As shown on the screen, a capacitor consists of two parallel plates separated by air or any insulating material such as mica. Unit of capacitance is farad. When current passes through the capacitor, the charge developed between the plates is proportional to the voltage across capacitor, that is Q is proportional to V. Q is equal to CV. Therefore, capacitance C is equal to Q divided by V. Linear elements. An element is said to be linear if its voltage current characteristic is at all times a straight line through the origin. A linear element is one which satisfies the principle of superposition, that is the principle of homogeneity and additivity. For example, the current passing through a resistor is proportional to the voltage applied through it, that is V is proportional to I. Example, resistor. Nonlinear elements. A nonlinear element is one which does not satisfy the principle of superposition, that is the principle of homogeneity and additivity. Example, diode. Lumped and distributed elements. Lumped elements. The elements which are separated physically are called lumped elements. The examples of lumped elements are resistors, capacitors, and inductors. Distributed elements. The elements which are not separated for an analytical purpose are known as distributed elements. For example, a transmission line which has distributed resistance, inductance, and capacitance along its length. Bilateral elements. An element is said to be bilateral if it has the same voltage-current relation for current flowing in either direction. Examples of bilateral elements are resistors, inductors, and capacitors. Unilateral elements. An element is said to be unilateral if it has different relations between voltage and current for the two possible directions of current. Example of unilateral element is diode.